Welcome back. This is our sixth and final video for Unit 5, and I want to take a look at something that I find fascinating as a tool for finding GCFs and LCMs, and it's the ladder method. So let me get you to a share, and we'll take a look at what we've got going on. Okay, ladder method, here we go from the current slide. Okay, I've borrowed this set of slides from a presentation, and you can see there that Becky Afghani is the originator of this set of slides. So I just changed a little bit of the look. All right, ladder method's a useful tool for finding LCMs and GCFs for numbers. All right, so look, I know the numbers aren't particularly difficult here. You got a 6 and an 8. So what you want to try to do is you want to find factors of both 6 and 8. And looks like 2 might work. So that's what you do. 2 will go into each of those. And 2 goes in there, and 2 goes in there. And then you ask yourself, are there still common factors of 3 and 4? And if there aren't, you're done. Okay. So I say, well, that was all well and good, and it wasn't particularly difficult to do. What good did it do me? All right. Well, as it turns out, what we will do is we find the least common multiple by multiplying all of the numbers that are listed down the left-hand side. So in this case, that's only the 2. Or I'm sorry, the LCM is all of the numbers, the 2 and the 3 and the 4. So if we multiply them all together, I'm sorry, I got myself confused on GCFs. The LCM is the product of 2 and 3 and 4, 24. All right, you say, well, geez, Dale, where's the greatest common factor? Oh, that's pretty catchy. The greatest common factor is going to be just the left side. All right, so LCM is a big old multiplication of all of the stuff, kind of makes an L, if that makes sense to you. All right. Okay, that's pretty cool. Greatest common factor, you've already heard me say, that's just going to be the numbers hard on the left-hand edge. In this case, it's the 2. It says we're going to do the product of all the numbers on the left, but it's kind of hard to do a product of just one number. So in this case, the GCF of 6 and 8 would just be the 2. If we had more factors on that left side edge, if our ladder had more rungs, we would have had more things to multiply together. Hopefully we'll get to see that on another example here. So again, on the context of what you've got there, the GCF is found by multiplying only the numbers on that left edge. There you go. Okay. All right. And in case you really wanted, you can use the ladder method as a means to simplify fractions. The reduced form of 6 over 8 is actually the 3 and the 4, the bottom numbers, if you have them right in front of you there. So 6/8 is reducible to 3/4. Okay, so the last 2 guys, if you are in the business of simplifying fractions, would give you a fraction. A little bigger number, so let's go get it. We got a 24 and a 60. So we'll find our first number that we think goes into both of those. Good, 2 does. So that'll be 12 and that'll be 30. And now, unlike last time, there are still factors that are common to 12 and to 30. We're not restricted to using primes. I have noticed that this PowerPoint tends to do that. So, all right, what will go into both 12 and 30? Well, you guessed it, another 2. Again, nothing magic. We could have used 3. 2 goes into 12 6 times. 2 goes into 30 15. And we're now down to where I don't think 2's any good, but I think 3 would be okay. So we'll take 3 into each of those. And we get a 2 and a 5. And I don't think 2 and 5 have any common factors other than 1. So our ladder is complete. And now you say, well, let's go get the things that we need to get. So if we're going to find the least common multiple, it's going to be multiplying all of those things in that L shape, a 2, a 2, a 3, a 2, and a 5. If we want to find the greatest common factor, it'll just be those numbers on the left side edge, the 2 and the 2 and the 3. All right, you ready? Here we go. Here we go. All right, LCM. 2 times 2 times 3 times 2 times 5, you guessed it, 120 would be the least common multiple for both 24 and 60. All right, greatest common factor, just that left side edge, 2 times 2 times 3, that would be 12. So the greatest common factor of 24 and 60 would in fact be 12. If by chance you were tasked with reducing the fraction 24 over 60, you could now claim that it reduces to 2/5. So like the ladder method, I think it's clean. I think it's easy to use. All right, so you say, all right, go ahead, find them. You got 28 and 42, just for hoots. 2 will go in. 7 will go in. Done. So you want LCM? Yeah. 2 times 7 times 2 times 3, 84. One greatest common factor, just 2 times 7, 14. If by chance you were tasked with reducing the fraction 28 over 42, 2/3. So I like it. It's versatile. It's not hard. I said in the discussion, the slides that you saw always use primes as factors. You don't have to use primes, and that's kind of, if you get bogged down on the whole prime factor thing, this gives you a little more flexibility, I think. So I like it. All right, extensions, some things you could think about. We're not going to get too crazy there. This, my friends, takes us to the end of our discussions for Unit 5, and this is your assignment 5C. Again, it's a section of problems from the book. Grab your paper, grab your pencils, crank out some PDFs, and shoot them out to the Dropbox. All right, that wraps our last discussion, and we'll be back soon with Unit 6. See you then.